Good afternoon, dear participants of the conference. I would like to present you a paper on intelligent forecasting in multi-criteria decision-making by Vladislav Borisenko, Galina Kondratenko, Evgeny Sidenko, and Yuri Kondratenko from Petromogila Black Sea National University. So, the analysis of the behavior of stock prices is characterized by the ambiguous behavior of the process, which is usually affected by many factors, such as trend, seasonality, the geopolitical situation, and others. Forecasting is a key point when making investment decisions. The ability to predict the behavior of stock for making final decisions allows you to make the best choice, which otherwise might be unsuccessful. However, this task is actual for the world and the whole international economy, since the possibility of accurate prediction of the value of the stock is closely linked to the financial gain of the companies. Accurate predicting the value of assets on the exchange will also help to reduce investment risk and protect the investment income from the market volatility. There are three different approaches to research and to predict the asset prices on the stock market, such as technical, technological, and fundamental analysis. In this paper, the combination of the first two approaches was used. A time series can be represented by four components: trend, seasonal variations, cyclical variations, and regular factors. The aim of the work is to compare stock price forecasting methods, their models, as well as parameters that affect the efficiency and accuracy of forecasting. The most popular forecasting time series models are after-regressive models with a moving average, and models derived from them. Thus, we will focus on these models. Models and methods are evaluated using mean average error and mean square error metrics. Also, the authors present five smoothing methods such as simple moving average, the weighted moving average, the exponential moving average, the double exponential moving average, and the triple exponential moving average. And also presented such models of after-regressive as simple after-regressive model, after-regressive moving average model, after-regressive integrated moving average model. We also considered artificial neural networks for forecasting, and for this study, Amazon stock statistics were taken from the official Nasdaq website for the past 5 years. Data set you can see on figure 1. The moving average method was implemented for various values of the n parameter of the previous time points number that had to be taken into account when building a forecast. You can see this on figure 2. It was checked that decreasing the n-window length model shows the more accurate results on the test sample, indicating that the latest data is most influential to the prediction. Also, for the exponential moving average, figure 3 parameter is at the level of the A smoothing coefficient, which represents the degree of reducing of weighting from 0 to 1. The lower the level of smoothing is, the more accurate is the forecast, as every previous reading weights more. On this slide you can see two tables. The first one consists the result of implementation of all smoothing methods, and you can see change different specific parameters for this method. And also in table 2 you can see execution results of all three models. And after aggressive integrated moving medium model is best according to MSE and MAE metrics. For more in-depth study of the model, 5 architectures were implemented in the paper. The accuracy of each of them is presented in table 3. According to comparative results, the dependence of the quality of the forecast on the number of nodes in the hidden layer, the optimization method and the activation function is completely traced. The best result was the MLP 20101 model with the Adam optimization algorithm and hyperbolic tangent as an activation function. Here is the graph of the price of stocks sold predicted by this model, as well as a graph of the forecast error on figure 5a and 5b. In this work, 5 different convolutional neural networks architectures were tested to analyze the effect of parameters on the prediction value of the shared 5 variants of the long short-term memory architecture were implemented. The CNN 10256-3 model with the Adam optimization algorithm and ReLU activation function showed the best result. The best result was shown by the LSTM model 1030-3031 with the Adam optimization algorithm and ReLU activation function and with the least lag window. The performance of classical algorithms and machine learning algorithms can be summarized in a comparative table 6, and you can see 3 model methods, their advantages and disadvantages. For example, ANN, artificial neural network, for this method technology, advantages are ability to handle complex nonlinear patterns, high forecast accuracy, but have disadvantages like require a large amount of data. So, as conclusions, for investors, capital management is becoming increasingly important today. Professional investment managers and individual investors tend to have effective tools for understanding the trends in the stock market to minimize investment risk and increase their profits. Some people believe that it is very difficult to predict stock prices. However, in the real business world, successful traders carried out thousands of transactions every day. Since the very beginning of the financial operators on the stock exchange, people developed a method to predict the value of assets in the future. With advances in computing technology and artificial intelligence, the accuracy of this methods is growing every day. In this paper, the authors compared the indicators for forecasting between the neural network and the classical time series forecast method, namely the value of the company's shares on the stock exchange. The analysis showed that the neural network models described in this study showed a very much better able to accurately predict and therefore confirmed the viability and the feasibility of using artificial neural networks for further study of their application in the financial markets. The predictive power of the model was influenced by different factors depending on the architecture and input data. Thank you very much for your attention.